So what are the units of the magnetic field? Now, if we know the formula, what we derived just now, we can write the formula as B equals to mu naught by 4 pi I dl sin theta upon r square. I can also calculate the value of mu naught by 4 pi. You already know what is mu naught, and mu naught by 4 pi is nothing else but it's a constant of proportionality. And if you simplify the whole value by taking r square I dl sin theta on the left side, we get this value mu naught by 4 pi. The value of this is 10 raised to minus 7 Tesla meter per ampere. So we came to know the unit for B, which is Tesla, which can be written in the different form. So this value can be written as Weber per meter square, and I can also get the another unit as Newton per ampere per meter. Now how do we get these units? For that we need to know certain formulas. What we have done, we know that phi of B equals to BA cos theta, such as we already know that phi E, that is the flux, is EA cos theta. Same thing I apply for a magnetic field, which is BA cos theta. So from this formula I know my magnetic flux is measured in Weber, so it's phi B is measured in Weber upon, I take this area down, which is meter square, and I get the unit for B. So I get this unit as B as Weber per meter square. Now we need this second unit. How did we get this? Newton per ampere per meter. You have learned this in 10th standard. F equals to I B L sin theta. You will be doing this ahead in the chapter. For time being, how did we get this unit? I am explaining you. So therefore F equals to IBL. If I take only these known values, this is force is in Newton, I is in ampere, L is in meter, we get the unit of B, that is Newton per ampere per meter. So I have one unit here. So you need to be very careful when we use the unit. This is my one unit, this is my another unit, and this is the unit, we call it as Tesla. That means for all these units we can say it's a Tesla. Also, the relation between the SI and CGS units of magnetic field. We know now the SI unit is Tesla, and in CGS unit we call it as Gauss. So there is a relation between both of them, and the relation is that 1 Tesla is always equals to 10 raised to 4 Gauss. Very important, and you should know this relation while solving numerical. Sometimes you need to know this particular type of conversion. Let's just go ahead and see the relationship between the permeability of free space, that is mu naught, and the relation between permittivity of free space, that is epsilon naught. Very simple, but still you need to know the relation. It's very helpful. We know that mu naught upon 4 pi is 10 raised to minus 7. If I want, I can write Newton per ampere square, and I also know that 1 upon 4 pi epsilon naught equals to 9 into 10 raised to 9, and the unit also we know, it's Newton meter square per coulomb square. If I divide both this equation, so if I divide, let's say it's equation number 1 and equation number 2, I divide these two equations, I get somewhere the relation as mu naught epsilon naught equals to 10 raised to minus 7 upon 9 into 10 raised to 9 If I simplify this ahead, I get this as 1 upon 9 into 10 raised to 16. What important thing to be noticed is the unit, C square per ampere square meter square. Now I know very well one relation which I can convert very easily, and the relation what we know is that I equals to Q by T. So this is Coulomb and this is ampere. So if I simplify this, I get T equals to Coulomb per ampere. If I square this, I get this as C square, this value, which is my second square. So if I look at this value, C square per ampere square, which can be substituted as S square. So if I substitute this value as S square, what do I get? It's mu naught epsilon naught equals to 1 by 9 into 10 raised to 16 S square meter square. So sorry, there is an error here, it's minus 2. I did mistake, it's minus 2. So S square, this, if I write this in the denominator, will be 1 upon 3 into 10 raised to 8 meter per second the whole square. So I know this value, it's 3 into 10 raised to 8 meter per second, it's C. So therefore this particular equation now will turn into mu naught epsilon naught equals to 1 by C square, or this square goes here, so it becomes root. So C, therefore C is equals to 1 upon square root of mu naught epsilon naught. So this is the relation between the permeability and the permittivity in a free space with respect to the speed of a light. They can ask this question in the exam. Find the relationship between mu naught epsilon naught and C. So you should know this derivation, a very small derivation, just understanding.